Okay, we're looking at part 2 in the notes for lost signs. And example 2.2, we're looking at case 2. We have two sides and an angle. And for this, we're going to get an ambiguous case, which means two possible triangles. So first we should find angle B, and we can use sine A over little a equals sine B over little b. To solve for angle B, I have to use the inverse sine, and I'll put this in my calculator. So whatever we get here for angle B, I'm going to have to then subtract that from 180 degrees to get the second possible angle B. So there's two angles that we're going to work with, and the problem's going to split in essentially two different problems. Okay, so let's see what we got for angle B. We got 44.8 degrees. What makes this ambiguous, this side-side angle, is this angle C right here. We don't know what it is, so side A could swing to make this triangle obtuse, like the left one, or acute, like the right one. So basically, angle B could be the 44.8, or it could be supplementary to that, as in the obtuse triangle, and be 135.2. So we end up getting two possible solutions in two triangles. So I would set up the information for triangle 1 and triangle 2 so we can keep track of the different solutions that we end up getting. So because we have a different angle B, means we're going to have two different angle C's as well. So once I know two out of the three angles, I can just subtract them from 180 to get my angle C. The last part is going to be finding C. So we've got C sub 1 and C sub 2 that represents the two different triangles. Well, I know all other 5 pieces of information. I just use my lost signs now to set up my proportion to solve for little c. Use my calculator, plug it in. Okay, so I get 40, rounding nearest tenth here for C sub 1. I'll put it in up there. And I know A sub 2 over sine A sub 2 equals C sub 2 over sine C sub 2. I substitute my knowns, and I find little c sub 2. So we don't always get ambiguous triangles for side-side angle, but in this case, because angle A is smaller, or side A is smaller than side B, we end up getting that swinging side that could be two possible answers. Okay, let's take a look at 2.3. This is also a case 2, but we'll see here that in solving for angle B, I end up getting 1.2 for sine B, and we know that you can't take the inverse sine of a value greater than 1. It means that the hypotenuse is smaller than the opposite side. And if you put it in the calculator, you should get an error, because it's not possible. There we go, error. So what does this mean? Well, if I try to make a sketch here, we'll see that side A won't be long enough to actually connect down to the third side. So there's no solution with this one. So let's take a look at this case 2 a little bit more. There's some more possibilities. One, that the A isn't long enough and there's no solution. But also, it could be just barely long enough that it makes a right angle with the base. Therefore, there's one solution. I could get that swinging side again that we did in the example 2.2. Or if A is larger than side B, I get one solution, because this can't swing around to the other side. And then if A is obtuse, angle A, then I have a situation where A is not long enough, or A connects with the third side, making an acute angle. Okay, so there are all the possibilities for case 2. Now try the practice set and see how you do.